Yeah, good morning everyone. Myself, Mr. Naresh, I would like to discuss about an important topic in ground improvement techniques. Today we'd like to discuss about the soil reinforcement. So generally, maybe that everyone knows that ground improvement techniques because it can be improving the strength and the soil reinforcement is in one of the ground improvement technique. It means in the soil reinforcement we are adding the reinforcement to the soil and then finally we got that enhancing the properties of soil and we got strengthening of it. So likewise here we are discussing step by step process. There is a different topics are there in the here. So if you see here, there is a reinforcement strip, and then there is an institute ground reinforcement, rock bolting, and grid reinforcement soil, and also reinforced with the strip, and also rock bolting, soil nailing, and ground anchors. Likewise, there is a different types of topics are here. So one by one we'll discuss in this session and this video. So if you see that there is an a first one here. Uh, so if we see this here, the first talk is in a reinforcement with a strip. So here if you see here, there is this is in a cross section of the ground. Generally if you see that whenever it is having the weak in nature, at that moment we are going to be place the strips. That means first we need to excavate the soil up to the depth of the foundation level. Then automatically what is happen, we need to place a one layer of the soil here, and then we need to place a reinforcement strip over that particular soil, and then providing the compaction with help of the maybe vibrating or dynamic rollers, and then finally again we are going to be place that there is one more soil layer and giving the compaction, and finally we are also going to be place one more layer of the reinforcement strip over that existing soil. Likewise this process is going to be repeated until up to the soil surface. So likewise what is happen when I am going to be apply the load here, so after placing or before placing. So if you before placing if you load here, maybe it is unable to bear the loads, but after replacing the reinforcement strip here, then automatically when you are applying the same load, then it can be resisting that loads. So likewise what is happen, this is a reinforced earth. So generally what type of elements are there in the reinforced earth? So there is one part is a soil and one more is in a reinforcement. So due to the maybe you got any doubt, sir, how the strength is going to be attained for the soil. Maybe what is happen here, there is a frictional bonding between the soil and reinforcement. So it will improve the high tensile strength while you are placing the reinforcement strip here. Then likewise what is happen, the strength is going to be improved. And if you see here, there is a grid reinforcement soil is there. So grid reinforcement means here we are placing the strip only, but here we are placing there is a grid wise reinforcement into the soil. Likewise for example, we are placing that there is a grid reinforcement soil. That means we need to excavate the soil up to here and then placing the reinforcement in a grid manner. Then again we are placing the soil in this over that particular reinforcement, and then again we are applying the compaction and providing the second layer of the reinforcement, and the first layer and second layer is going to be combined together. So likewise if you observe here in the figure, so likewise here there is a grid type of model we are going to be placed in the soil. So likewise if you see here, so we are not going to be connected the one layer of reinforcement with another layer, but in the case of the grid one, we are connecting the one layer of reinforcement to another one. Likewise we are providing a grid reinforcement. So likewise it will give them a more strength than this soil reinforcement strip. And then if you see here, there is a reinforcement strips likewise we are providing. So that layer wise, if you clear diagram here, so this is a reinforcement strips, then we are providing likewise. So this is the reinforcement strips we are providing likewise layer to layer like a sandwich manner, and the soil we are going to be compacting, and then provide provision of this reinforcement over there. So this is a clear diagram for the soil reinforcement strip. So due to the frictional forces and then the strength is going to be improved because of this. And also we'll see that there is the next one is in situ ground reinforcement. In situ ground reinforcement, if you see this figure, in situ ground reinforcement, that means here we are excavating the soil in the above method, but here we are not going to be excavated anything, just we are placing that there is a reinforcement inserting into the ground itself, so that what is happen, there is a cost of the treatment is going to be less. But when compared to the remaining one, the first one, this method is not that much of importance or not efficient, because in the first method we are giving the compaction of the soil here, but in the case of second method, what just we are placing the reinforcement itself. We are not disturbing the natural soil, but in the case of the first one we are disturbing the existing soil and providing the compaction for it to get the densest packing, so that the strength is improved. Likewise, in the case of in situ ground method, what is happened, we are just replacing the reinforcement inside of the ground. And likewise we got all those things. And if you see that the next method, so in the case of the rock bolting, so if in the rock bolting, I will show that figure here. So here there is this is in a sloped rock is existed. So here the sloped rock weathering is going to be takes place. Weathering is means maybe because of rains and because of temperature, the rock is going to be fractured slowly, and then it is degraded, and then finally what is happen, it is separated from the parent rock, and finally landslides is going to be takes place. So likewise this is a problem in the case of the sloped surface if it is in a rock. So that if you see this figure, and then here there is a bolting is going to be done. That means we are introduce a drill hole inside of the rock, which can be penetrated from up to the certain depth of the rock, and then we are applying a bonding material or sealing material over there and introducing the reinforcement, so that the sealing material is creating the bonding between a reinforcement over there and inside of the rock, so that this bolting we are going to be provided that holding the children rock by parent rock, so that automatically it can be improved. Without this support it can be splitted and then it can be fall down. So likewise we have a rock bolting is there, and when we are applying, when it is having the weak rock over the slopes areas and hilly areas, then we need to provide in this kind of technique. And coming to that, next one is a soil nailing. So in the case of the soil nailing and rock bolting, almost is same. If you see here, there is a figure here. So here also sloped soils are existing. So in the sloped soils are existing means we need to go for a soil nailing. So in this soil nailing also, we just introducing the reinforcement inside of the sloped layer, and then finally what is happen, we are introducing the element over here, and then we are going to be fixed here. So likewise we are providing the soil nailing. It means it is holding the mass. That means we are placing the plate over here and applying the bolting inside of the soil mass, so that it can be holding, it may creating the tensile forces. So likewise we are providing the soil nailing. So where we are applying the soil nailing, so I will give them one practical example regarding the need of the soil nailing. Recently that Kerala is having a lot of floods. So due to that floods, the sloped surfaces is going to be takes place in the landslides, and finally there are a lot of people are died at that moment. So now what is happened that we need to locating the sloped surfaces, and it may not resisting any weathering factors, it is not stable. At that moment we are going for a soil nailing. So that means if you see this figure, you can understand easily. This is a sloped area, it is unable to resisting any weathering factor, so that slowly it can be fall down. So that's why we are introducing the nails, likewise above method only. Likewise introducing but we are placing the plates in the case of the soil netting, or maybe if the plates are not made, we are also going to place the grids also. And then we see that there is an a next one, load transfer mechanism. So in the load transfer mechanism, how the load is going to be reinforcement into the soil. So actually, if you see here, there is a frictional resistance. Frictional resistance already told in at the starting itself, due to the frictional bonding, it may giving the strength to the soil. So likewise, the tension is going to be generated in the that is a reinforcement leads to improve the load bearing capacity, and there is an a stability of the soil. So likewise here, what is happened, we got an a there is a different types of methods are there, and now I will discuss about that. There is a what are the advantages of this. So what is the advantages? The main advantages, it can be improving the bearing capacity of the soil, and also it may improving the slope stability, and also it can be resisting the more loads, and at same time it can be reducing the earth pressure and retaining the structures heavily. And it is very effective in the case of the installation process when compared to the other one. That's why the cost of the method is very low when compared to other methods. So maybe these types of techniques are all useful for maybe coastal soils and as well as the coastal soils. So coastal soils we are going to be preferred because it is having the less bond in the case of the when compared to the coastal soils. Coastal soils is having the less bond, so that here we are going for there is this type of technique in the case of the coastal less soils, or maybe rock soils which have a weak strength. So likewise here, if you see here, there is different types of rock bolting, soil nailing, and also grid soiling, and this is a technique. It's very important. Now I want to revise it once again. So that like a PBL oriented, I want to explain it. So PBL, what is a PBL here? Actually, problem based learning. So in the problem based learning means we need to identify the problem first. So here recently in the Maharashtra, that because of heavy rains, rock mass is going to be fall down suddenly. So because of that, I think so many people are died. It is not happened single time, it's happened twice in a year, or maybe twice in a within 3 months of duration. So likewise, it is it look like a disaster only. It's not much of the disaster. Maybe it's a disaster. Likewise, it's a big problem for them. You want to stay at that particular locations. For example, you want to make them in a particular locations. Then we need to go for in a ground improvement technique like this soil reinforcement or rock bolting. That type of techniques we are going to be introduced. So here, how can we introduce? First, we need to check that what is a core of the rock, that how much level it going to be having a depth, and then finally we need to clean the debris over there, and then finally we need to drill the hole, and then we are having a capping materials, or maybe capping material we are introducing to the drilling material, and then now we are introducing into the reinforcement, and we are going to be fixed with the core material, so that it will give a more strength. So even though there will be a fall of heavy rains, maybe in the next time it not going to be takes that much of disasters here. So likewise, what is happen, this technique is going to be suitable, and this technique is suitable for rock sloped areas, and as well as the maybe in the case of the Kerala incident also. So I will give the local example regarding. So in the local example regarding, recently there is a Khammam to Kodad highway. There is a road extension is takes place. There is a highway bypass. Previously it is in a single lane actually, but now unfortunately it is in a there is in a 4 lanes because the bypass, and it's also one way. It's happened, but the road travel, or maybe a road laid in between the hills, so they are cutting the hills because of laying the roads, so they are leaving the rock likewise only, because it is in the strong condition. But if in the case this rock is there in the weak condition, at that moment they are living likewise only, at any moment it going to be fall down over the roads. So this isn't a problem, maybe the road user is going to be placing, or otherwise any heavy air takes place, or maybe any rainfall it takes place, maybe it's not in a problem now, but in the future it is in a problem. So if you want to prevent this problem in the future, it's also we need to go for a rock bolting. So that means we need to introduce the drilling at outer surface of the road, and then we are introducing the capping material, and then we are introducing the reinforcement and providing the bonding, threading over there, and bolting over here, and then finally you got any strength there. Likewise we are going for there is a soil reinforcement, and also I will give one more example regarding. So in this one more example, there is a, for example here there is a black cotton soil is there. In the black cotton soil it is unable to bear the load, because because of Mount of Morillonite, largest swelling and shrinkage is going to be takes place, and settlement is also going to be takes place. So at that moment it's not supported. You want to construct in a heavy or high raised buildings, then we need to introduce the soil reinforcement. We need to cut the soil, and we need to place the reinforcement, and then we need to fill the soil and give the compaction, and then finally we are also going to be repeat the process until up to it is reaches to the top surface. And the same phenomena we are generally seeing in the case of the flyovers. In the flyovers everyone knows that there is a facing elements are there, hexagonal facing, in between there is a soil is going to be facing. That reinforcement means everybody thinking that here only we are going to use steel only. No, different types of the reinforcements are available. Polyester polymers are there, grit polymers are there, different types of polymers also we are going to be utilized as a reinforcement. Anyhow, any doubts regarding the soil reinforcement, I will clear the doubts in the classroom, and thank you.